Hello everyone, I am Stefan Judis and welcome to the Rapid PhantomJS video tutorial. I am a front-end developer and I maintain two open source projects that use PhantomJS. By the end of this course, you will learn how to use PhantomJS to make your developer life easier. You will know how to check your projects right after a new release for broken layout via screenshot capturing, how to obtain useful data about network traffic without doing it yourself manually, and how to get the result of your unit test suites quickly. You will be able to use PhantomJS and to write your own scripts to automate tasks you have to deal with every day. And this is what PhantomJS is about, automating and speeding up your developer performance to not spend time on repetitive tasks. Because it is the first video of this section, let's have a quick look of what is actually included. In this video, we're going to take a look at what PhantomJS is. Many people use PhantomJS today and there are a lot of tools coming up using this technology. So let's understand why it is so popular and why people are so excited about PhantomJS by looking at examples for the main use cases. Later we will install PhantomJS and we'll learn how to kick off PhantomJS over the command line. Because that is what it is. PhantomJS is a command line tool that ships without a graphical user interface. We can only use it over the command line or with other automated tools. And then we are ready to use PhantomJS and to write some basic scripts. These scripts will use the Phantom, System and Web Page APIs of PhantomJS. These APIs are the building blocks of PhantomJS, and that is why we will have a brief introduction to each one of these. Understanding how these APIs work is very important for us to interpret our own scripts in section 2. So let's just dive in and answer the first question. What is PhantomJS? PhantomJS is a web browser that we can control from the command line. It comes without any graphical user interface, which makes it perfect to use for automation. In this series, you'll learn how to automate testing, run screenshots comparisons, and handle many useful tasks with it. Because it is so useful, PhantomJS is used by a lot of famous open source projects like Bootstrap, jQuery Mobile, and Modernizer. PhantomJS.org is the website of PhantomJS, and we will visit this page a couple of times, for example to install PhantomJS and to read the documentation of certain functionalities included in PhantomJS. PhantomJS is based on WebKit, which is the engine that powers Safari. To mention other engines, there are Gecko, which is the base of Mozilla's Firefox, Blink, which is used by Google Chrome, and Trident, which is used by Microsoft Internet Explorer. Command line browsers similar to PhantomJS are available for Firefox and Internet Explorer too. If you're interested in those, check out Slimer.js, which uses Gecko, and Trifle.js, which uses Trident. This means that 3 of 4 major browser engines can be tested and controlled via the command line, which is pretty awesome. The fact that PhantomJS is headless is its main advantage. The browser overhead to give the user an interface just does not exist. Using a headless browser, you can open web pages, render HTML, parse CSS, and execute JavaScript. And all can be controlled via the command line. With this functionality, completely new options for automation come up. For example, you can test your JavaScript, render images of websites, and basically do everything that is possible inside of a browser without all the overhead that normally comes with the real browser. And this is why people are so excited about this technology called PhantomJS. Because it gives us the possibility to automate and test our daily work easily and quickly. The 4 main use cases of PhantomJS are testing, screen capturing, page automation, and network monitoring. Testing is what PhantomJS is used for the most. Let's assume you're working on a JavaScript library that you maintain, and in your mind your changes are completely working because you tested it manually. But just as you are about to deploy your changes to production, a PhantomJS script stops your deploy because some of your unit tests fail, which you hadn't noticed. This is just an example of how PhantomJS can help you avoid breaking existing functionality. Also, if you're working on a quite large site, how great would it be if you could get rendered images of all subsites of your site right after a new release? Let's think of 50 sites. Checking for broken layout on such a large number of pages manually can take a long time. PhantomJS can do that for you easily. Additionally, you can use it to automate user behavior. Let's assume you want to check the correct responses after a visitor has submitted a form. With the help of PhantomJS, you can write a script that loads a website and fills out a form and checks the responded results of this form submission. And the last use case is network monitoring. Website performance is getting more and more important these days. You can use PhantomJS for counting requests of a specific type to easily notice when someone added some performance decreasing source requests to your project. As we can see, PhantomJS has a lot of use cases to help you avoid broken code in production, to make quality assurance easier, and to speed up and improve your development. To sum up this video, we covered what PhantomJS is and explained what headless actually means in the context of PhantomJS. In the next video, we will check out some detailed examples for use cases of PhantomJS to make it really clear what to actually do with this browser controlled via the command line. I hope you enjoyed this video and I am excited to show you some cool PhantomJS scripts in the next video. Bye! Welcome back to Rapid PhantomJS. In the previous video, we covered what PhantomJS actually is and had a look at the main use cases that this software provides. In this video, I will show you a couple of example scripts that will show you how powerful PhantomJS is. So let's start and recall these four main use cases. As already discovered in the previous video, these use cases include testing automation, which includes the running of a frontend unit test suite easily in PhantomJS and capturing the results without the need to check it manually. There is also rendering and rasterization of websites, which means that we have the ability to capture screenshots of any website available on the internet. Then there's also the area of page automation, which means that we can automate any user behavior using PhantomJS. This includes filling out forms, following links, clicking buttons, and basically everything a real user can do on your website is doable using PhantomJS. And at last, there's the use case of network monitoring, which means that we can easily keep track of any request that is made by a website. Automating the monitoring process can help to drastically improve the performance of a website. These four areas are also included on the really good PhantomJS examples page, which you will find at the PhantomJS website at /examples. The example page includes a lot of ready-to-use scripts. So if you're looking for an already functional solution to solve any particular problem, this site is definitely the place to start your search, and the chances are quite high that you will find a solution for your problem over there. I will show you a few examples for each of these areas now. And to do so, I will open my command line or so-called terminal. If you're not familiar with the command line, you can find the command line on Unix systems like Linux or macOS under terminal, and on a Windows machine you can find it under command prompt in your applications. Let's start and have a look at how PhantomJS can help us automate front-end testing. If you're not familiar with front-end unit testing, it basically works with the so-called testrunner HTML file, which includes your unit testing framework and then runs your unit test suite inside of the browser. The testing framework will show you the results of your test suite inside of this HTML file. The hard thing is that you have to open the test runner manually and check the results by yourself by loading the page. This checking and opening of your test suite can be automated with PhantomJS. So let me just show you what a test runner looks like. Here we see a test suite done in Jasmine, which is my preferred frontend unit test suite. We can see that it executed 53 specs and that they all passed. So let's get the result using PhantomJS and switch back to the command line. I already installed PhantomJS and that's where I have the PhantomJS command available. Don't worry, we will cover how to install it in the next video. If I now execute this script called run Jasmine.js by typing in PhantomJS run Jasmine.js and additionally enter a website that includes the HTML test runner, PhantomJS is doing exactly the same task as I did manually before. It visits the page that includes the test suite and waits for all tests to be done. It then reports the result of the unit test suite. This means that you can run your test suite easily multiple times without doing any manual work. This works perfectly with a continuous integration system or any build process you like. So let's move on to page rendering. To demonstrate this, I will execute another prepared script by typing in PhantomJS run-rasterize.js http packedpub.com packed.png. This command will let PhantomJS execute the script run-rasterize.js and accepts two additional arguments. This means the script accepts a URL of the site we want to visit and a particular file path, which will be the location of the newly rendered image. When I now execute PhantomJS run-rasterize.js, what happens is that PhantomJS visits the given URL and renders an image out of that website. And done. Let me just open the generated image by typing in open packed PNG and running the URL on Google Chrome to prove that this actually worked. As you can see, the rendered image of the packedpub.com website is exactly the same as the content I see here inside of Google Chrome. Using this technique, you can render images of any website available on the internet. This can help you when developing websites because you can perform layout checks in a really nice automated manner and save a lot of time in the process. The next example will be of page automation. I will execute a script called one2follow.js. This script will visit twitter.com and evaluate the number of Twitter followers I have at the moment. And here we are. This shows that PhantomJS has access to HTML, which is served by any website. And we can easily read out and modify this website using the PhantomJS API. We will cover how to do so in detail a couple of times during the series. What you have to keep in mind is that everything a human visitor could do, you can do using PhantomJS. This includes reading data like a real human would, but also it can interact with a website like a real human would. We will now cover network monitoring. If you're a front-end engineer, you most likely monitor network activity all the time, and probably do it manually by opening the developer tools of your choice or by using external tools. With the help of PhantomJS, you can automate this task. So let me show you the script one2loadspeed.js. This script also accepts one additional argument that represents the website we want to visit. We set this argument as the website of Packed Publishing. The script visits the site packedpub.com and evaluates the time that is actually needed to load this site. Reduced loading time is a really valuable metric to improve the overall performance of a website. But this is just a really general example. Let me move on to a more detailed one. The script one2netsniff.js will evaluate and monitor all requests that are made by a given website. The output includes response times, status codes, and HTTP methods, just to mention a few metrics. Using this script, we can get data about all of the network activity quite easily using PhantomJS. This can be extremely valuable for generating performance or network reports. And these were the basic examples for this video. I showed you some scripts about testing, rendering, page automation, and network monitoring. I hope you're as excited as I am about PhantomJS and have discovered the power that this technology has to offer. In the next video, we will finally dive deep and install PhantomJS. Then we will write and execute our first basic script. So see you in the next video, and I hope you enjoyed this one.
Hello everybody, you're watching Rapid PhantomJS Section 1 Video 3, which will show you how to install and use PhantomJS in your environment. In the previous video I showed you some nice use cases for PhantomJS, and you are now ready to get your hands dirty and start working with PhantomJS. To start using PhantomJS we have to install it first. We can then write and execute our first script. To install PhantomJS you can download the binary package directly from the PhantomJS website at /download.html. This is the best option for Windows users. After the download, unzip the archive, and inside of the unzipped folder you'll find the PhantomJS executable. Then you have to tell Windows where PhantomJS is located on your machine. You can do so by right-clicking on Computer and choosing Properties. Click on Advanced Settings. Then click on Environment Settings, select the path field in the System Variables and click on the Edit button. Now add the file path to the unzipped PhantomJS folder at the end of all the paths that are already included. Make sure to divide the last and the newly added path with a semicolon. Click the OK button and reboot the machine. And that's all it takes to make PhantomJS available on the command line on a Windows machine. For OS X users I recommend using a system package manager. For instance, on my OS X machine with Homebrew installed, I can install it with the following command: brew update and brew install PhantomJS. If you're using the other popular package manager on OS X, Mac ports, you can alternatively execute sudo port self update and sudo port install PhantomJS. After that, you're basically done on macOS. If you're on a Linux machine, you can also download the binary package or use the dependent install package manager. The commands to do so differ depending on your Linux distribution, but you can check the PhantomJS download page for further instructions. Unfortunately, the distribution-specific PhantomJS package may not always be on the latest stable version. To get the latest stable version in your Linux environment, I recommend to build it from the original source. If you're working on a machine with apt-get installed, for example you're working with Ubuntu, you have to execute these commands. And if you're on a machine with yum installed, you have to execute these commands. If you need further information, you can look up the build instructions at the PhantomJS page at /build-html. There's one other way to install PhantomJS through Node.js. Node.js is a platform built on Google Chrome's JavaScript engine V8. It lets you execute JavaScript on any machine. So if you have it installed in your environment, you can install PhantomJS using the Node package manager that comes with Node.js, called npm. The command would be npm install -g PhantomJS. This is my preferred way, so let me install it via npm. And here we have it. Node.js runs on every environment, so this works on Windows, Linux and macOS. To use PhantomJS, open the command line of your system. In Unix environments, the command line is called terminal and can be found in your applications folder. If you're on a Windows machine, you can go to Start, All Programs, Accessories, Command Prompt. Then when you start the command line, you have to check if the installation of PhantomJS was successful. We first type in the command for PhantomJS. Then we will ask which version is actually installed on your environment by appending --version to the command. Then press enter. If the installation was successful, it will return the current version of your installed PhantomJS. And if this works properly, we are ready to write and run our first script. Open an editor of your choice. I'm using Sublime Text 3, and you can now start writing your first basic script. This script will actually just say hello to you. This is the most common starting point in the programming world and is called the Hello World example. To achieve that, we will simply use the console, which you may be familiar with if you have ever written some front-end JavaScript. The console includes this one command to write strings to the command line called log. We can pass any string to this command and it will display it later on. We will use this command a couple of times to output data to the command line during this course. Afterwards, we have to inform PhantomJS that we are done for now and that it should exit the process. To do that, we have to type in phantom.exit and execute it. Now we have finished our first script and all we have to do is to execute it via the command line. So think of a place where you want to keep your scripts and save it there. Then we have to navigate to the path of our first script file using the cd command. In my case it is users, Stefan, sites, pack publishing, rapid PhantomJS, section 1, code. Executing PhantomJS always works in the same manner. You have to type in the PhantomJS command and what follows is the name of the script that is to be executed. In this case, we have to type in PhantomJS and then append the script name after entering a space. We will learn how we can pass in some more arguments on the command line in the video 1.5 that covers the system API. So let's execute it and check it out. It says, hey, welcome to Rapid PhantomJS. Perfect. To sum up this video, we covered the installation process of PhantomJS and got the basic understanding of how to execute it via the command line. In the next video, we will really start using PhantomJS provided functionality and we'll write more scripts to get you familiar with the APIs that come with PhantomJS. I hope you enjoyed this video and I can't wait to show you more cool stuff. So see you next time. Bye. Hello everybody, you're watching Rapid PhantomJS section 1 video 4, which will give you a brief introduction about the Phantom module and its API. In the previous video we installed PhantomJS and wrote our first Hello World script. We should feel comfortable about using and executing PhantomJS now and can start developing useful scripts. If you want to look up the documentation for the Phantom module, you can go to the API documentation and then choose the Phantom object. But before we really start writing complex scripts, we should have a look at error handling in PhantomJS. Error handling is very important because we are headless and we should be always informed about what is going on and especially what went wrong. We will have a more detailed look at how to exit PhantomJS. We already used phantom.exit in the last video, but this only included an ideal case scenario. We should know how to exit in case of an error and keep a log of when something went wrong. Afterwards we will implement real error handling, which should be included in every script to keep us informed about things that went wrong and to help us handle exceptions properly. To get started, let's have a look at the Hello World script we wrote in the last video. It included a basic console log and exited PhantomJS properly. The provided function exit is also able to accept one argument. This argument is the so-called exit status code. By default, PhantomJS will exit with the status code 0, which indicates a successful execution. So let's change that and pass the status code 1 to the exit function. If any executed program or software exits with the status code of a positive integer, this means that something went wrong. And here we can see that the command line is reporting that the program did not run properly by showing this, fail 1. In this implementation, the status code 1 does not make much sense, because the script did what it was supposed to, printing out a hello world message. But this just leads us right to the next topic of this video, how to handle unexpected errors and exceptions in PhantomJS. To handle errors and exceptions in PhantomJS, the Phantom API provides a basic error handler that we can use. If you have already written some JavaScript before, this pattern may feel very familiar to you. All we have to do is to find a function for phantom.onError. This function will be called in case of any unexpected or uncatched exception or error that may appear. I already prepared a little snippet to output all the error information in a nice detailed manner. This snippet will print the error and show us where in our script it appeared by printing out a step trace. After printing out the information, we will exit the script with the status code 1, which is a big warning sign that something went wrong. And to see if it works, let's just throw a test error and check if the error handler gets triggered. So let's execute the script. We now see what error happened and where it appeared, which is very valuable information for us while developing scripts. So let's remove our error again, and we now can be sure that we will be informed properly in case of an error. This pattern will be included in all of the following scripts to make sure we see the errors when they appear. A friendly suggestion: I highly recommend that you implement error handling in PhantomJS scripts, because this will help a lot while debugging to know what is actually going on. If you want to write scripts for automation, then proper status code handling is really important to integrate your PhantomJS scripts in your dependent system. To sum up this video, we covered error handling using the Phantom module and build up the base for writing complex scripts. In the next video, we will have a deeper look at the system module to work with system arguments and check out the system information available inside of PhantomJS. I hope you enjoyed the video and you know that the base for good scripting starts with good error handling, especially in PhantomJS land. Hope to see you next time. Bye.
Hello everybody, you're watching Rapid PhantomJS Section 1 Video 5, which will give you a brief introduction to the in PhantomJS included system module and its API. In the previous video, we built up a foundation to write good PhantomJS scripts by implementing proper error handling for our future scripts using the Phantom module. In this video, we will extend the Hello World script by reading out system information, and we will have a look at how to read out system arguments to create generic scripts that do not include hard-coded information. This is because writing generic scripts is always much better than writing scripts for specific use cases. The module we need to use for that is the system module. So let's open the dependent script, which is called 1.5 system API.js. Now we have to tell PhantomJS that we want to use the included system API. Unlike the steps we followed for the Phantom module, which is available globally, we have to use a so-called require function to load the module. This can be done by simply typing in var system equals require system. The require function is a globally available function to load modules or even files. This function is part of the so-called CommonJS specification and is included in PhantomJS and in any script that is executed in the Node.js context. So in this case, we are loading a global module by just using its name, system. Moreover, it's also possible to load other JavaScript files by handing in a given file path. It is good practice to put these kind of statements and assignments on top of our script. So let's stick to that. What happens here is that we load the system module with the CommonJS specification, which is used by PhantomJS. We assign it to a variable called system so that we can use it later on. The system module provides a lot of useful information, especially if you want to run your PhantomJS scripts in different environments. This can be useful to treat special cases for different environments. For example, say we want to read the operating system information. In this case, we can easily get the OS property of our new system variable and can read out information like architecture and operating system name. So let's extend our log message to show us on what kind of machine this script is executed on. The most important aspect of the system module is probably its ability to read out system arguments that are passed to the executed script. The next goal is to extend this script to read out these system arguments. We then should be able to call our script with a third parameter that includes our name. For that we can use another property of the system variable. What we are looking for is the args property. This property is an array of strings that includes all the arguments that are passed to PhantomJS when the scripts are executed. In our case, the array has the length of 2. It includes at index 0 the name of the file we executed and at index 1 our name as system argument, which in this case is Stefan. The number of arguments has no limits, so we can easily pass as many arguments to our script as we like. This can become really handy if you want to pass multiple configurations to our script. So let's just assign the passed name to a variable and then log it via the console log statement. Let's just execute our new modified script and yay, here we are.
Hey Stefan, how are you doing? You're on a 32-bit Mac machine. You executed 1.5 system API.js.
Perfect. Now we are almost done. And just to show you another best practice, let's keep track of when we're using the script incorrectly. For that, let's just implement a small condition that checks the arguments array for the length of 2 to make sure that the name was passed to the script correctly. If it was not, let's just throw an error. Our already implemented error handler will deal with it. Now we have a generic script that can ask any number of people how they are doing and gives additional information of the particular system as well. To sum up this video, we covered the system module of PhantomJS and extended our Hello World script to accept system arguments, show information, and to be kind to us if we're using it incorrectly. In the next video, we will finally arrive at the web page module and load the first website and check out what PhantomJS has to offer over there. Hope you had fun and see you next time.
Hello everybody, you're watching Rapid PhantomJS section 1 video 6, the last video of this section, which will give you a brief introduction to the included web page module and its API. In the previous video we extended our Hello World script to read out system information and actually read out past system arguments. We used this information to show the user a well-formatted output and to inform him or her if he or she is using our script in the wrong way. In this video, we will implement the web page module and will load a website for the first time and render a screenshot of the loaded page. Because of the knowledge you have already gained about error handling and reading out system arguments, we will extend our script to open any website defined by a system argument. To finish this section, which includes all the fundamentals to really get started with complex PhantomJS scripting, we will render a basic image of the opened website. As we have learned, PhantomJS is a headless JavaScript scriptable. And now that we know the basics of good PhantomJS scripts, it is time to load our first website. To do that, we need to use the web page module provided by PhantomJS. Loading this module works the same way as loading the system module. We have to require and load the module on top of the script by just typing in var page equals require webpage.create. The module already provides a function called create, which will return a new instance of this module. We then have to assign this new instance to a variable, because we want to use it later on. Additionally, we get the desired URL from the system arguments, and we will assign this to a variable called URL. This way we can use the same script for multiple websites, which can come in handy in the future. Thus, we easily implemented a new system argument and loaded the web page module. So let's just modify the existing log messages to show us the URL also. And modify the checks for proper script execution by changing the number of expected system arguments. Let's make a quick check to see if everything is working as expected. Looks pretty good. Now we are ready to load our first website. The web page module provides a lot of useful functions that are ready to use. The functions range from cookie handling, setting the size or the zoom factor of the particular window, to JavaScript execution, which will be really important to use later on. In section 2 we will use this module for page automation, advanced screenshot rendering and network monitoring. And it is by far the most powerful module that PhantomJS has to offer. For now, let's only check out the open function. This function expects 2 to 4 arguments, and we will use the basic version with 2 arguments. This is a common pattern in JavaScript, giving the option to use a different number of arguments. The only thing you have to keep in mind is that the callback, which I will explain in a second, has to be the last argument. The first argument defines the actual website we want to load. Fortunately, we set this one already up, so we can easily pass the URL variable to it. The second, and in our case last argument, is the callback. If you're not familiar with callbacks and asynchronous programming in JavaScript, let me just give you a quick explanation. JavaScript includes this principle of callbacks. Callbacks are actually functions that will be executed when something is done. In our case, the callback function will be executed when PhantomJS loads the page that we defined. And here comes the first trap when dealing with JavaScript and asynchronous programming. When we implement the open function in our script, we have to make sure that the phantom.exit call will be included inside of the defined callback function. If we forget to move it, PhantomJS will quit just before it is able to load the website, because the callback will be invoked later on. The order in which the statements are included in our script does not matter in this case, because callbacks can be executed at any time and it does not matter where they are defined. So let's just call the page open command. The callback function will be invoked with a status argument. This argument will give us information about success or error. And because we are headless and we basically have no clue what is going on, let's implement some logging for this status argument. The render function of our web page object expects a string that defines the path to the rendered image. And it is really as easy as that. So let's check if the image will be rendered by executing our script and opening the image. Looks pretty good to me. To sum up this first section, we covered the usage and installation of PhantomJS, checked out some complex scripts to show off all the options of PhantomJS, and learned how to implement the system, Phantom and web page module. In the next section, we will implement nice examples for page automation, page rendering, network monitoring, and testing by ourselves. So I hope you are as excited as I am about the advanced scripts in section 2. I will see you next time.
Hello and welcome to section 2 of the Rapid PhantomJS video tutorial. In the last section we talked about the 4 main use cases of PhantomJS. Let's revise them. These were page rendering, page automation, network monitoring and testing. And in this section we will write scripts that will cover each of these areas in detail. You're watching the first video, which is about page rendering, but before we start writing a nice script that renders a whole page or only parts of it, let's just check why we should use PhantomJS for page rendering. I prefer PhantomJS because I am a front-end developer who easily has to deal with large websites that include a lot of different subpages with a lot of different layouts. When working on big projects, I as a front-end dev can never be sure if I have not broken something on a completely different area of the page. That really depends on the CSS codebase, but having an automated way to check all critical areas of a large website makes me feel much more comfortable when developing. And especially since responsive web design is not only a nice thing to have, but rather a necessity, websites get more and more complex. If you're not familiar with the term responsive web design, let me just show you a quick example. CSS Tricks is an awesome resource for all CSS related topics. If you don't know it yet, you should definitely check it out. And when we visit the page and we resize our browser window, we will see that the page will look different depending on our screen width. This principle makes websites more accessible for a wide range of devices. That is perfect for your visitors, but additionally, it increases the complexity of developing these kinds of websites drastically. So what we do now is we write a script that takes pictures of the site with different viewport sizes, so that we can easily run it later on and make sure that everything looks good and as we expect it to look. Let me just open my editor. What you see here is the script we developed at the end of section 1. It already includes proper error handling
and is able to accept command line arguments, so that we can define the page we want to open with PhantomJS. Then the script loads a given page and renders an image out of that, using the page render function. We will now extend this script by setting a particular viewport width, and this can be achieved super easily. The page object provided by PhantomJS includes a property called viewport size. So all we have to do is set a new viewport by assigning an object to this property. The object has to include two properties. There's on the one hand the width, and on the other hand the height of our desired viewport size. The height actually doesn't matter, because the render command will render the whole page anyway in this state. So let me extend the script by setting the sizes just before we trigger the page rendering. We will render the page in 3 different widths: 1200 pixels, 800 pixels and 500 pixels. Additionally, I'll change the rendering command to include the viewport width inside of the file name, so we can figure out later on which image belongs to which viewport size. So let's execute the script and pass the URL to it. And here we are. Let's have a look at the rendered images. As expected, we rendered 3 images in 3 different viewport sizes. And as you can see, the website of CSS Tricks looks slightly different depending on the viewport width. To check this all the time can become a lot of work by doing it manually, and as you see, our tiny script can help us a lot already. You hopefully can see the value of this. When developing big websites, we will now be able to check the layout of important parts easily and quickly without opening our browser, clicking around and changing the viewport size manually all the time. This can help speed up things a lot, especially when dealing with responsive websites. That is working great so far, but let's now imagine we don't want to render the whole site all the time, because we are only interested in a particular area of the open page. The page object provides another property for that, called clip_rect, with which you can define that you want to rasterize only specific parts of the page. So let me just show you how it works. Let's say I'm really interested in the header area that is shown to mobile devices with viewport width around 500 pixel border. All I have to do is set this property to the page object by assigning another object. This object has to include the top and left positions and additionally a height and width value. We're interested in the header now. We know that the images should have the top and left position 0. We also know that the screen width is 500 pixels already, and the height is free for us to choose. So let's just take 300. Let's execute this script now. And here we are. A nice little picture of the header of the mobile version of CSS Tricks. This can be extended to any area on the page, so you can probably already think of a use case for that. And this is it for page rendering today. We had a look at the properties viewport size and clip_rect and developed our own script to take pictures of websites in different widths and even different parts of these websites. I hope you enjoyed it, and I hope you can't wait to take screenshots of all of the internet. In the next video we will go into page automation, which will include reading out data from web pages and actually filling out forms and following links later on. So see you next time. Hello everybody, you're watching Rapid PhantomJS section 2.2, which will show you how to use automated scripts to read out the data of any website. In the previous video we covered how to render complete pages or only specific parts of pages using the page render command of PhantomJS. In this video we will go into reading out information that is included on a website, and we will use PhantomJS to display this information on the command line. The page we work with is the website of Pack Publishing. Let's have a quick look of it now. We will write a script that will read out the information of the current bestsellers published by Pack Publishing, which you will find on the middle of the website. So how do we achieve this? To read out the information of a website, we have to check the actual structure of the served HTML document. Google Chrome is my browser of choice, and to inspect an element included on a website, you can easily right-click on it and choose Inspect Element. Other browsers work in a similar way. After doing so, the developer tools will be opened and they are already pointing to the correct element. So let's inspect it. What we are looking for is a way to select these bestseller elements. The best way to do so is by using an element including an ID. The ID attribute in HTML is a unique identifier, and we need something unique to select elements with PhantomJS to not run into the trouble of selecting the wrong elements and retrieving the wrong data. In our case, we're lucky, and the whole container where the bestsellers are included has the ID featured books inner. That's perfect for us. What we now have to do is to figure out a selector to retrieve the actual titles of the bestsellers. Maybe you are familiar with JavaScript selectors. If not, I recommend you to check the excellent documentation for selectors included in the Mozilla Developer Network. You will find the link for it included in the slides. One working selector for our use case would be #featuredBooksInner and .bookBlockTitle. This selector means we are looking for all elements included in the element with the ID featuredBooksInner that have the class bookBlockTitle. We can easily check if this is working by prototyping the selector in the JavaScript console of the developer tools. To do so, you can either go into the separated tab for the console, or you can easily open it by pressing Escape on any area of the Chrome developer tools. The function we will use for that is called document_query_selector_all, and this function will return the elements that actually fit with our selector. Great, it's working. We got the elements using the selector as the return value. It's worth mentioning that there are a lot of other useful selectors, like for example the descendant or the adjacent sibling selector. You can find the links to these specific selectors in the slides too. After this, we are ready to go and can open our editor and start writing the script to read out this information. So let's check this script quickly. It has the same structure as the script in the last video, so you already know what is happening in here. I removed the system module because this script is tightly coupled to the pack publishing website, and we no longer need to pass command line arguments. The URL is now set to www.packpub.com, and the page object is used to load the actual website. What we have to do now is extend the functionality when the page is loaded by using a function of the page object called evaluate. Evaluate takes a callback as argument. This callback will be executed in the current context of the loaded website. This means that we can use and access all global available objects like window or document inside of this function. This function is basically injected and executed the same way as we would type something in the JavaScript console in our developer tools of choice. This callback can then return any object that can be used back in the PhantomJS context. This is essential for PhantomJS scripting. So let's have a quick look at a slide summing up the relation between the actual PhantomJS script and the page evaluate function. What we see here is a basic PhantomJS script. It's surrounded by an orange border. We can require PhantomJS modules and the global Phantom object is available. The script includes the page evaluate function. And inside of this function, the context actually switches. That means that the callback function has no access to the global Phantom object anymore, but rather all the traditional browser global variables like window and document are present. So it is possible to read out or modify the website. Let's switch back to the editor and add our selector to the evaluate function. One problem right now is that document_query_selector_all will return a so-called node list. This is an object that kind of behaves like an array and it includes all the elements that were selected. But we are actually only interested in the title of the bestsellers. So we simply write a quick loop to read out the titles of the elements by using inner HTML and push it to a separate array called bestseller data. Because inner HTML can include white spaces at the beginning and end, we additionally call a trim function to get rid of these white spaces. The last thing to do is return our newly created array so that we can use it in the PhantomJS context. Great! Now we have implemented the reading of the data that is included inside of the pack publishing website, and we only have to print this data out. For that, we just need to iterate over the data we just retrieved through page evaluate and print it out via console log. So let's save our script and execute it to see if it really works. Great! This way we are now able to read out any information we like that is accessible on the internet. We can easily extend this to show, for example, the news from your favorite news website. I bet you already have something in mind where this might be useful. And this is it for now. We had a quick look at the Chrome developer tools and wrote a script to read out any information on a website using the evaluate function of the page object included in PhantomJS. In the next video we will start filling out forms to really automate the behavior that is expected from a human visitor on a website. So see you in the next video and I hope you enjoyed this one. Hello everybody, you're watching Rapid PhantomJS section 2.3, which will show you how to use automated scripts to fill out search forms and read out the results afterwards. In the previous video we covered how to read out information of the pack publishing website without interacting with the actual website. In this video we will go the next step and start to interact with the website. This means we will load the pack publishing site, fill out the search form in the header, press the button and wait for the search results page to read out the list of results for this particular search. So let me open the pack publishing website. The first step is actually the same as the one in the previous video, which was page automation 1. We have to analyze the website to get to know what the elements are that we want to interact with. To achieve this, we open our developer tools and analyze the search form. To do so, just right-click on the search input field and click on Inspect Element. When inspecting the actual markup, we'll see that a lot of elements inside of the search container has an ID. IDs are the HTML attributes we should be looking for. What we need are two elements. First of all, we need to fill out the input of the search form, and after that we will need to click on the button to actually trigger the search and load the search results page. Fortunately, both elements include an ID. The search input field has the ID main search keys, and the submit button has the ID edit submit 5. With this information we are ready to start scripting and open our editor. And here we are. What you see is the base script for this video, which will be already familiar to you. Error handling is nicely implemented and I already prepared the script to work with system arguments, so that we can define via the command line the actual search term we want to fill into the search box. There's only one difference as compared to the script of the previous video. At the bottom of the script you see the already known command page open, but now we will not pass the callback function to it, which will be triggered when the page is loaded. The reason for that is that we have to react to the finished loading of two different pages. Once we loaded the index page of pack publishing to fill out the search form, and a second time when the search results page is loaded to read out the results. To execute the code on the loading of these two pages, PhantomJS provides an event handler called onLoadFinished. This event handler is a function that will be called when the page object has finished loading a website. So let's just assign a function as the event handler and check if it works. Great. Now we have to figure out on which page we actually are. This function will be called twice when two different pages have finished loaded. So we need to evaluate which page finished the loading process. Unfortunately, PhantomJS provides no way to give us this information, but we can easily get this information by ourselves by using page evaluate and reading out the current window location href, which represents the current page location. Let's add a simple condition that will be like, if we are on the index page of the website, please call a function called filloutForm. And if not, which means that we have to be on the search results page, please call a function called readoutResult. So let's just implement these two functions. The function filloutForm has to fill out the input field in the search box and has to click the button to submit the form. Fortunately, we already know the required selectors and can easily fill out the form using the page evaluate function. We now implement the filling out of the form by simple DOM manipulation and click on the search button. This can be achieved by setting the value attribute of the input element to our search term, which was passed via the command line. The button can be clicked on by just calling the click function of this element. Alright, now comes the key point of our onLoadFinished event handler. PhantomJS will perform these commands and will automatically load the next page. It will call our listen again so that we can then call our readoutResult function, because we are not on the index page anymore, and read out the actual search results to display them. So let's implement the readoutResult function. This function performs the same actions as the script of the previous video. It will search with a given selector, which I already prepared, named .panelCallLast.bookBlockTitle, and read out the titles of the search results. Afterwards, it will prepare the data to actually print it out nicely on the command line. When these lines are not completely clear to you, feel free to check out the previous video, Page Automation 1, where we dealt with selectors and the page evaluate function. The functionality is the same. Basically, it reads out the given elements, prints it with PhantomJS, and then exits PhantomJS by calling phantom.exit. Let's execute our beautiful script. We have to pass in the search term to our script, so let's just choose JavaScript right now. And go. And here we see the result. These are the results that are shown when searching for JavaScript material on the Pack Publishing website. And this is it for today. We filled out a form, waited for 2 pages to be loaded, and read out the shown results. I think that's already pretty good and useful. In the next video we will monitor network traffic, which can be, especially when you're a front-end developer, super useful to spot performance bottlenecks. So see you in the next video and I hope you enjoyed it. Hello everybody, you're watching Rapid PhantomJS section 2.4, which will show you how to use PhantomJS to monitor network activity. In the previous video, we covered the useful use case of how to automate customer behavior, like filling out and submitting forms of a website and reading out the displayed results of this form submission later on. In this video, we will cover the topic of how to monitor network requests. During development, this is a metric that every developer should check on a regular basis, because it is one of the main metrics for developing good, fast websites. We should always remember that performance matters. And just because images are usually the most heavy part of any website, we will implement the counting of the requested images of a website. The workflow for this is usually this. Load a website in your browser of choice, open the network panel, and check the network activity manually. But this takes time and can be overlooked for this reason. So let's see how we can automate that and make it more convenient and streamlined during development. You will be surprised how easily this can be done, because you have already reached a state of knowledge where you can achieve such tasks without breaking a sweat. So let's open the editor. Here we are. I have already prepared a script that will be the base for this video. We will make use of the system module to read out a particular URL that is specified in the system arguments and fetch the network activity data of a given website. Additionally, we will use page open without passing the callback function to it. But as we saw in the previous video, this is not a big deal, because we define an event handler for pages that have finished loading, via page onload finished. Inside of this handler, we call phantom.exit to tell it that we are done. And this is basically our setup. Nothing new included. So let's check how to monitor network requests.
The PhantomJS page object provides another property called onResourceReceived.
Similar to page onload finished, we can assign a function to it that will be called every time a resource is requested. So let's do it. This function will be called with a response object that holds a lot of useful information. Included are, for example, the given content type of the resource and the URL that was actually requested. So let's check if this function is already called by logging out the content types and executing the script. Great. Now we see a lot of different content types, but we are only interested in the images. So a simple condition will help us monitor only requested images. There's only one pitfall with using this function. According to PhantomJS documentation, this function will be called several times for the same resource, if a larger resource is requested. So these resources will be counted multiple times, but we only want to get informed when the request actually started. This can be done by extending our condition with a check for response stage equal start. One last thing to do now is implement a counter. Seeing all the network requests is nice, but the sum of it is also a valuable metric, because 20 new image requests will probably slow down your website noticeably. We will increment the counter every time PhantomJS recognizes an image and print it out later on inside of the page onload finished function. So, execution time. Excellent. What we see now are all the images that are loaded when visiting packpub.com. And on the bottom we see that this website initially loads 29 images. And this is it for today. With only a few lines of JavaScript, we were able to monitor all the image requests that were made by a particular website, and this can easily be extended for your use case. So maybe you are interested in something completely different but needed the same base logic recovered here. You will now be able to implement this without much effort. In the next and last video of this section, we will check how test runners for front-end testing frameworks work. So see you in the next video, and I hope you enjoyed this one.
Hello everybody, you're watching Rapid PhantomJS section 2.5, which will show you how test runners for front-end unit test suites in PhantomJS work. In the previous video we covered how to monitor network activity, such as counting the requested images. In this video we will go into the last main area of PhantomJS use cases, and we'll check out how unit testing frameworks in the front-end area work. With the unit testing harness we can test some parts of a website or a web application in isolation. PhantomJS will allow us to automate testing of CSS and JavaScript resources. We will have a look at an already written test runner, which makes it possible to run and get the results of a test suite. Before we get started, let's have a look at one such test suite. So let's open Google Chrome and see a functional unit test suite that includes two simple tests. Here we see the output of my preferred unit testing framework, which is called Jasmine. So what is actually going on here? When we open the page, the Jasmine test suite will be executed, and this test suite will run a couple of predefined tests. And we see here two tests were successfully executed and were fine. If you're not familiar with the functionality of front-end unit test suites, I will show you how these tests are defined in a second. Basically, it's about comparing values all the time. The test suite loads, executes functions, and expects a particular state or return value. For example, in line 9, we've got a globally available function addNumbers, and we execute it passing two arguments to it, and assigning the return value to the variable result. Afterwards, we have to check that the result is what we expected. We're expecting the number 3 in this case. And when we now check our displayed result, we see that we received a green message for this test. Not much magic about that. To test it further, we could change the expected value to 4 and see the test suite failing. The thing to know here is that Jasmine writes all the markup we see in the example page by itself. Basically, the HTML document we loaded here has no markup and will all be filled with test results generated by Jasmine. To check that, let's check the spec runner HTML file quickly. As you can see, only the script and link tags are included. Additionally, two JavaScript files are loaded to the Jasmine test suite. These two files will define the two functions we want to test later on. And then the spec files defining the tests are loaded too. And that's all we need. The workflow to automate this is the same as the one we used in the video number 2 and 3 when dealing with page automation. First we have to analyze the website we want to automate and find out which elements included in the website hold the needed information. The primary thing we want to know is what the final result is, correct? So let's check where this information is held. As we can see here, it is included in the element matching the selector .alert greater than .passingAlert .bar. So let's remember this one for later. And let's check out the runner script. The nice thing about these test runners is that there's probably already a test runner written for PhantomJS for your preferred unit testing framework. You have nothing to worry about as far as the runners are concerned. We just want to check it out now so that we know how it actually works. This is the most complex script in the whole Rapid PhantomJS course. But don't worry. As mentioned before, you usually don't have to deal with it by yourself. So what is included? We see here our known page open command to open the HTML page where the test suite is included. Then there is a check that will inform you right away in the case of loading if there was any trouble in loading the website right away. If everything was successful, a function called wait4 is executed. So let's have a quick look at it. This function looks very complicated, but all you have to know is what it does. It repeatedly executes the function that you pass to it as the first argument until it returns a value of true. This means you can perform checks that are dependent on time and execution of other things. The wait4 function will check in a short interval if your condition already passes. So what is the condition in this case? In line 62 we see
that there is a page evaluation function running, which we have performed ourselves already. And this evaluation is checking for the presence of a particular element. This element is the loading spinner of the Jasmine framework. If this loading spinner is not present anymore, we can be sure that the test suite executed all defined tests. Afterwards, the website is scanned for failed messages, because this is what Jasmine does. It will append elements with the class failed to the DOM and will show you where something did not run as expected. If there are any failed specs found, the script will just log them to the command line and will exit with the status code 1. This is best practice, and if you don't recall it clearly, you can check out the video about the Phantom object to refresh your knowledge. So if there are no failed elements found, the script just grabs the message on top of the page and prints it to the console. And here's our selector. Nice. Lastly, we will exit PhantomJS with the status code 0, which means all good, and we're done. Let's execute the script to prove that it actually works. Great. Have you noticed something interesting? Basically, apart from the wait for function, unit testing works exactly like the practices we covered in the video Page Automation 1 and 2. It is only about reading out information, logging it to the command line, and exiting with the appropriate status code. It is as easy as that. And this is it for section 2. We covered rendering and rasterization and rendered nice images of websites. We covered page automation and filled out forms and read out any data included in a website. We monitored network activity and checked how many images were downloaded on a website. Finally, we had a brief look at how unit test runners work in PhantomJS. I hope you now feel ready to write your own scripts and are having as much fun as I am bringing this knowledge to you. The third and last section will show you how to implement these new scripts into your workflow to make your web dev life easier. So see you in the third section. Hello everybody, you are watching Rapid PhantomJS section 3.1, which will give you a quick introduction to the tools that are available to automate your new PhantomJS scripts. In the last two sections, we basically covered a lot of PhantomJS functionality, going from rendering and automation to testing. And now we will discover the final aspect of this course. How will this fit into our workflow? When dealing with PhantomJS scripts, it is especially important that one is able to execute them easily and in the best case scenario automatically. Having this functionality means no one has to remember specific commands and/or care about these commands. So let's have a look at what we will cover in this section. This section includes 3 videos. The video you're watching now, the first one, is just about showing and explaining what these tools are and what advantages they provide. In the 2 videos that will follow, we will discover the tools in detail and will set up the automation process from scratch. In the video number 2, we will have a look at the tools make and npm scripts. And in video number 3, we will have a look at the front-end JavaScript build tools Grunt and Gulp, which have become industry standard lately. So what is Make? Make is definitely the oldest software that we will cover in this course. It was invented in 1976 and is widely supported in all Unix environments. This means when you're on a Linux machine like Ubuntu or on a Mac, you will be fine. If you're in front of a Windows machine, you have to install it first. And there are plenty of instruction guides available on the internet. What all of the tools covered in this course have in common is that they have one command that will deal with PhantomJS execution. We don't have to remember anything about location and system arguments. These tools will help us in case we forgot how to deal with our scripts. So let me just show you how this will work. All we have to do is navigate to our directory and type in make into the command line. What we see now is the execution of a script that we developed in section 2, which takes screenshots of the packed publishing website. This command is defined inside of the make file, which is the configuration file for make and has to be located inside of the directory where you want to execute make. We will have a detailed look at the make file in the next video. The main advantage of these kind of tools is that they are easy to remember and, more importantly, easier to share with coworkers and other maintainers of your project. This gives you the ability to standardize across projects to a single command for test execution, for example. Another option could be the usage of npm scripts. We already mentioned Node.js and its package manager npm in section 1. As a quick reminder, Node.js is a platform that lets you execute JavaScript on the server side, which brings the advantage, especially when you're dealing with web development, that you can write application, testing and automation code in the same language. Node.js and its ship package manager npm have become very popular over the last few years, so you might not want to include another dependency like make in your process. A notable thing about npm is that it not only runs on every platform, but its functionality isn't limited to package installation processes only. You can also use it to execute any commands, including the execution of our PhantomJS scripts. So let's have a quick look. I'm executing the command npm test, and the same script will be executed as before using the make command. What's nice about this is that it is a convention for Node projects to include this command. So if you're developing a project that is based on Node.js, you may feel familiar to execute a test suite using the npm test command. We will now have a look at two new popular build tools written in Node.js. Grunt and Gulp are build tools that have plugins to accomplish many common tasks. For instance, we can run unit tests, concatenate and minifile files, and prepare a project for deployment according to best practices. With Grunt and Gulp, we'll be able to add automation to our project, so that we can run our PhantomJS scripts with a single command, or even as a hook with our source control system. So let's just have a quick look at the plugin pages of these two tools. The Grunt plugin page is located at gruntjs.com/plugins, and the Gulp plugin page is at gulpjs.com/plugins. Both tools provide a really rich plugin range, so you will find a plugin that fits your needs quickly. Additionally, these two tools come with a so-called file watcher that will automatically run the scripts you like whenever you change a file included in the project. We will have a look at this in more detail in the video about Grunt and Gulp. Watch can be extremely useful for noticing breaking changes on the unit test suite. For example, a use case can be when making changes to a JavaScript codebase to run the unit test suite right after each file change. Just to show you what the output of Grunt and Gulp looks like, let's kick it off on the command line. So let's now execute our PhantomJS scripts using Grunt, and now we are doing the same using Gulp. And this is it for now. We covered 4 main build and automation tools, and hopefully you are already curious about them. They all provide useful functionality for automation. Over and above that, Grunt and Gulp provide a huge ecosystem to automate common tasks quickly. All things considered, you have to decide by yourself which tool fits best with your project. In the next video, we will develop the execution of our PhantomJS scripts via make and npm scripts. So see you next time. Hello everybody, you're watching Rapid PhantomJS section 3.2, which will show you how to implement the build tools make and npm scripts. In the previous video, we had a nice overview of all the tools that will be covered in this course. And in this video, we will implement make and npm scripts by ourselves to make the execution of our PhantomJS scripts easier for other developers and to execute it on different servers or continuous integration systems. The goal of this video is to develop the base config files for both tools so that we don't have to execute PhantomJS by our own anymore. From now on, that will be the job of the automation tools. So let's start with make. Make and basically all build and automation tools are based on a specific config file. In the case of make, this file is called makefile. This file needs to be placed in the project root. So let me just create a new file called makefile. We will now execute one of the scripts we already developed in section 2. I already prepared a scripts folder that includes the script for rendering images of given URLs. The configuration of a makefile is fairly easy. Makefiles work with the so-called targets. You can simply define targets by giving them a name followed by a colon. So let me just include a target called test. Inside of this target, we can then easily place shell commands that we want to be executed. I'd like to have a nice message that says PhantomJS has started. Afterwards, we'll execute our PhantomJS script by passing the URL of packed publishing to it. So let's give it a try. Great, it's as easy as that. There's only one tiny thing to add. We'd like to have this command as the default one. This way, we don't have to remember any targets or anything else and can simply call this target by executing the general make command in the command line. To define the default targets, a target called all will be executed when we execute make without specifying any target. Let's check that. Great. Now we're able to execute our developed PhantomJS script by just typing in make into the command line. Make can be easily extended with anything you can think of. And because it's so widely supported, using make is a good choice. It may not have all the features we will discover when learning about Grunt and Gulp in the next video, but it's definitely an option.
So let's move on to the next possible tool to use. If you don't want to introduce another dependency and you're already using Node.js and its included package manager, npm scripts is also an option. To run and use npm scripts, you need to have installed Node and npm globally. If you already have, we can easily set up the configuration file for executing our PhantomJS scripts using npm. The configuration file for npm is called package.json, and this file also needs to be placed into your project root. If it's not a project that already uses npm, we can create this file by calling npm init over the command line. This command will start a prompt that helps us create a valid package.json file. Basically, the package.json includes all the information regarding this project. This includes name, version, dependencies, and our required scripts. So let's inspect the generated result. All we have to do now is add our script to the scripts section. It's quite normal for projects to include an npm test command. So let's just include our PhantomJS script as the test command for this project. And now we can execute our script to generate screenshots easily by running npm test. And this is it for now. We covered make and npm scripts as automation build tools. In the next video, we will have a look at the new front-end build tools that offer a bit more functionality, like file watchers and already written plugins. So I hope to see you in the final video of Rapid PhantomJS and hope you enjoyed this one. Hello everybody, you're watching Rapid PhantomJS section 3.3, the last video, which will show you how to set up grunt and gulp to run your PhantomJS scripts. In the last video we had a look at the traditional command make and at execution and automation via npm scripts. In this video we'll take a look at the new Node.js based front-end build tools that have been available for a while now. So let's just dive in and kick this video off by setting up a grunt task. Grunt is a Node.js based task manager that provides thousands of plugins and a fairly easy setup, as we'll see in a second. For running commands via grunt, you firstly need to have grunt installed globally on your environment. You can do that by simply executing npm install -g grunt CLI. When this is done, we have to set up the configuration file, which is called gruntfile.js. We can define several tasks inside of this file. These tasks are basically grunt plugins, which we have to install first. I decided to use a grunt plugin called grunt shell. We can easily execute our PhantomJS scripts using this plugin. So let's simply install this plugin by execute npm install --save dev grunt shell. The flag save dev will automatically add our new dependency to the package.json. If you need any further information about how to set up grunt, there is an excellent getting started guide included on the website gruntjs.com. So let's check the grunt file now that we are ready to go and have installed all dependencies. First of all, we have to register the new task by calling a pre-installed grunt function called load npm tasks. Then we can use this plugin. We have to set up the task with a couple of lines that are described on the plugin documentation page. Here we see the definition of the task itself, and inside of that we can easily run our custom PhantomJS script. So let's check if it works and run grunt on the command line. You have to keep in mind that this is only a basic example of how to use grunt. Grunt can be extremely powerful, and there are many more functionalities available than just executing a shell script. If you're curious about more plugins and predefined tasks regarding PhantomJS, simply navigate to the plugins page of gruntjs.com and look for PhantomJS plugins. But let me just show you one of the most powerful features that are included in these build tools, the file watcher. To set up a file watcher in Grunt, you have to use a plugin called grunt contrib watch. And to show you the advantage of using this file watcher, let's implement the unit test suite we developed in section 2. We can easily implement unit testing into Grunt by using the Grunt plugin grunt contrib Jasmine. The setup flow is the same as for the grunt shell command. We have to install the Jasmine and watch plugins using npm install, and afterwards load these plugins using grunt load npm tasks. So let me paste an already prepared configuration into the grunt file. To run our unit test suite, we have to define the source and spec files. This is similar to the example we developed in section 2. All the other tasks, such as dealing with PhantomJS and setting up the runner HTML file, is all handled by grunt contrib Jasmine. Inside of the configuration of the watcher plugin, we have to define which files should be watched for changes and which tasks should be executed if there was a file change. So in this case, we'll run the unit test suite whenever there are changes to the JavaScript source files. And when you now start grunt watch and make some changes to the source files, you see that the tests are running continuously right after performing a save. So if I now break the functionality of the add numbers function we developed in section 2, we'll get immediate feedback that we have broken something. Watch can be set up for any task, and that makes it extremely useful. It helps you write better code and gives you instant feedback. Using Watch will help you process, minify, uglify, and do nearly anything you can think of when developing not only PhantomJS scripts, but rather everything that is front-end related. So let's move on to see the other build tool included in this video, Gulp. The base principles of Gulp are basically the same as grunt. We have to first install it globally using npm install -g gulp. The config file is called gulp-file.js. We will follow the same method and use a Gulp plugin for executing shell scripts using the task manager. So let's install the plugin called Gulp Shell using the command npm install --save dev gulp shell. As you can see, these tools have a lot in common in terms of setup. And then let's check out the configuration file of Gulp. Writing Gulp configurations is more like writing scripts in Node.js. Gulp has to load the module using the CommonJS module specification, which is generally used in Node.js. After that, we have to define our new PhantomJS tasks, and then we're basically done. So let's execute everything. As you can see, the output of Gulp is more colorful, and additionally you have some timing information about when something is done. That is because Gulp cares a lot about being fast using Unix pipes. And this is what is different in comparison to grunt. If you're interested in knowing the differences between these two build tools, which is a hot topic inside of the JavaScript and Node.js community, running your query on Google will definitely give you answers. Gulp also offers a lot of plugins, so just browsing through the plugins page of Gulp will definitely be fruitful. Just like grunt, Gulp offers a file watcher, Gulp Watch, that can be set up as quickly as the setup was in grunt. Grunt and Gulp are definitely awesome tools that are worth checking out and trying. And this is the end of our crash course in PhantomJS. We had a look at the main API of PhantomJS and saw a lot of use cases of PhantomJS to increase productivity and avoid repetitive tasks. We developed our own scripts for rendering, automation, testing, and network monitoring. Additionally, we had a look at common tools such as Make, npm scripts, Grunt, and Gulp to implement automation using PhantomJS. I hope you had as much fun as I have had bringing this to you and will now start developing your own scripts using PhantomJS. Thanks for watching, bye.